Hello friends, welcome to Susan and John MathTube. We continue with vectors, triple products and product of 4 vectors. So the first question which we are going to do is product of 4 vectors. Now look at this, there are two things which we want to do. One is to create a number or a scalar with 4 vectors. And that can be accomplished if you simply do A cross B dot C cross D. Think about it for a minute. This will be a vector, this will be another vector. So the operations are valid. And when you take the dot product, the answer will be a number or a scalar. Now, if you find A cross B cross C cross D, of course, the answer will be a vector. So this is the scalar product of 4 vectors and this is the vector product of 4 vectors. Okay, so let's try to find the values, and if you can remember the values, it's like what you call very nice. So let's try to evaluate A cross B dot C cross D. The method is like what we did to the last problem in the last video. We will call the first vector as U. So this is equal to U dot C cross D. If you watch the last few videos, you might understand why I did this. So I'm going to call the first vector as U. And once I do that, I have a scalar triple product right in front of me. Look at this. There are 3 vectors U, C, D, 1 dot and 1 cross, and the brackets are for the cross product. And that is an STP. And remember, in an STP, you can like what you call interchange the dot and cross according to your convenience, right? So what I'm going to do is I'm going to write this as U cross C dot D, because I told you we can interchange the dot and the cross in an STP, because that's the definition of STP. Okay, now what is this U? Oh, U is A cross B. So we get A cross B cross C dot D. Can any one of you recognize this? If you said it is a VTP, then your subject knowledge is a little bit in question mark. Because in the first video itself I told you, vector triple product means there will be 3 vectors and it will be joined by cross, but the bracket will be for the last 2. So what we do is we are going to apply a trick you learned long back. Suppose you have the cross product of D1 and D2. And if you want to interchange the position of D1 and D2, that is you want to write D2 cross D1, then it will be negative of each other because the direction will change. Geometrically, the direction will be opposite. If you want to make this into a VTP, you have to write C cross A cross B. That means you have to interchange the positions. And when you interchange, what should we do? You have to put an extra negative. Now do you recognize this? Of course, you have to recognize, you must recognize it is a vector triple product. What is it? It is a vector triple product. Now, what is the formula for vector triple product? Do you remember? Last video also we discussed about it. It's very easy. CBA minus CAB. You got it? CBA minus CAB. Put 1 dot, bracket. Put 1 dot and bracket. Now look at this. First of all, I'll take this negative inside. So this becomes negative, this becomes positive. I'm going to reverse it. I think you already know minus of A minus B means the things will get flipped and you will get B minus A. So I'm going to write this as C dot A B minus C dot B into A dot D. Okay, for some students there might be some trouble. Look at this. Suppose I am doing a vector simplification that you learned in class 12. And in class 12 you might have learned problems like this. Look at this, we have 7 into A. 7 into A means a vector is being multiplied by a number. Exactly something like this. Look, a vector is being multiplied by a number. You have to understand the dot product is a number. So this is actually a number. This is another number. So it looks something like this. So if you want to perform this operation, you can distribute this C over the dot product. So you get 7 times A dot C minus 3 times B dot C. So what will be the answer here? C dot A. It is a number. You have to realize that it's a number. But mathematicians don't use the word number. There is a reason, because complex numbers may also be a part of it. So it's better to call it a scalar. Minus, if you study higher algebra, you will understand why the word scalar is used. Okay, that's it. That's it. Now we have to make it like very, very neat. So look at this. The order is like what you call A and then B and then C and then D. Okay, anyway, I'm going to write this as A dot C, B dot D for a particular purpose, B dot C, A dot D. Now I'll show you one magic. Determinant. A dot C, A dot D, B dot C, B dot D. Do you remember how to expand a determinant? A, B, C, D. 8 times D. Look. Oh, that's exactly this. Minus this. Okay, so we are done with. And remember, this is called the scalar product of 4 vectors. Now let's go for vector product of 4 vectors. A cross B cross C cross D. And it is better to by heart the result. There are 2 possible results. It is better that you by heart at least one of them. Anyway, I know one of them by heart, one of them I had to check some material. So the first result goes like box A, B, D, C minus A, B, C, D. It's very easy to by heart, so I kept it in my mind. It's, look at this, A, B, D, C. And next one is A, B, C, D. And there is yet another option. If you want, you can by heart it, so that the C will come inside the box. A, C, D. What's the missing thing? B. Minus B, C, D. What's the missing thing? A. Okay. I'll prove one of them. The other one is homework. So I'm going to prove this. My favorite one. Okay. If you want to prove the first one, it's very easy. Come on, come on, come on. We had been doing it from yesterday. So we start with the left hand side. So remember, this value and this value are equal. You can use any formula which you wish. If you want, you can use the above formula, or if you want, you can use the below formula. Anyway, I told you my personal favorite is the above one. So the left hand side is A cross B cross C cross D. Now think, what was the method? Yeah, just call this as U, so that we get a vector triple product. Come on, come on, come on. Don't tell me you don't recognize this. This is a vector triple product. Now, what is the formula for vector triple product? U, D, C minus U, C, D. Put dot, put bracket. Put dot, put bracket. Now what will we do? We will plug in the value of U. So what is U? Come on, Don't tell me you don't recognize this. Think about it. How many vectors? Come on, come on, come on, come on. Think about it. What is this quantity? It's an STP. There are 3 vectors, 1 dot, 1 cross. I'm not explaining. So here we go. A, B, C. Oops. A, B, D, C minus A, B, C, D. That's it. The proof was pretty simple. By the way, if you want to prove the second expression, I told you there are 2 possible values. If you want to prove the second expression, what you do is you start with the LHS. And then what we do is we put this part as U. Now don't tell me this is a VTP. This is not a vector triple product. So we interchange. Now this is a vector triple product. Now I'm leaving the remaining proof. Try to prove it, because sometimes they may ask, prove that this is equal to. Now this is from your question paper. Please mark it important. So the question is like, prove that scalar triple product A cross B, C cross D, E cross F. I saw this in 1 or 2 or I think 2 question papers. Okay. Now look at this. I have already done this question 2 or 3 times. So I know like what you call where we eventually will end up with. So my advice is, before starting this problem, because they are going to ask this for 5 marks, the first thing to do is you derive vector triple product. So what will you do first? First of all, you prove that A cross B cross C cross D. What's the formula? A, B, D, C minus A, B, C, D. So I'm repeating, you prove this. The first thing to do is you prove this. I'll repeat again and again and again. Prove it for exam. Okay, now let's start. And you can do that proof in a separate box or something. Now let's start. So what's the left hand side? Triple product. In the last video we did 2-3 questions in scalar triple product. So you know what to do. Write the 3 vectors in brackets. Do you remember? We did 2 or 3 questions. Then put 1 dot and 1 cross according to your requirement. If you already proved it, you can apply it here. So how do you apply the formula? It's very easy. C, D, F minus. Okay, now look at this. When I applied this formula, I can understand I did not get what they asked, right? I did not get what they asked. So that means I had to apply the other formula. I had to apply the second formula. Did you get it? So they may ask 2 different answers, so please be aware of it. We will go for the second formula. What is the second formula? A and jump to CD. ACD. Who's the missing one? B. Minus, you start with B. BCD. Who's the missing one? A. Okay, so let's start once more. Left hand side is A cross B dot. Okay, let's try with the second formula. A cross B dot. Okay, tell me the second formula. Very simple. You start with the first one, skip the second one, EF. Now I am happy. I can see the same thing here. Who's the missing one? B. Minus, start with the second one, D, E, F. And the missing one is C. Now look at this. I told you this is a number. Come on, how do you evaluate A dot 3B plus 7C? Very simple, right? You distribute this. Now can you see this is a number? Look, this is a number, this is a scalar, this is a number. Can you see that it's a number? Yeah. Okay, so when you distribute, we keep the number cross B dot D minus, we keep the number A cross B dot C. Now you know, you don't need my help anymore. What is this? Come on, come on, come on, tell me, what is this? It's an STP. So we get to prove what they asked. CF, ABD, you can check it. ABD, CF, ABC, yeah, that's it. Okay, now we have one more question. Yeah. So the question is, prove that I cross A cross I plus J cross A cross J plus K cross A cross K is equal to 2 times A. So look at this. Before we start, you have to understand one thing very, very clearly. I don't know how good you were in your class 11, 12 and 10. So I'll just tell the basic stuff once and then we will proceed. Look at this. I have written I, J, K in cyclic order. Now the trick to memorize I dot J, etc. is very simple. If you ever see I dot I, that means unit vector dot unit vector, the answer will be 1. At the same time, if you see I dot J or I dot K or K dot I, if you see any mismatch, the answer will be 0. Is that clear? Now, in the case of cross product, if you move in the same order, in the anti-clockwise order, for example, if someone asks you what is I cross J, you can easily answer K. But if you move in the wrong order, for example, if someone asks you what is K cross J, you have to tell minus I. Is that clear? And in cross product, if you have the same vector, answer will be 0. You can note it down. It's not only for this problem, it will be helpful in other problems also. What we do is, we start with a vector A. Let it be A1I plus A2J plus A3K. Now what we do is, I'm going to find what is I dot A. By the way, don't forget, dot product is commutative. That means A dot B and B dot A gives us the same answer. But it is not true for cross product. A cross B will be negative of B cross A. So this is going to be I dot A1I plus A2J plus A3K. You can distribute I over the dot product. So what will we get? Come on, think about it. What is I dot A? When we distribute, we will get A1 plus 0 plus 0. So basically you have to understand, I dot any vector will be the I component. Similarly, J dot any vector will be the J component. You can do it, it's not that hard. And K dot any vector will be A3. So the first thing to do is, you have to call this as equation number 1. I'm sure that you're wondering what exactly am I doing here, but this is very important. You will understand in 1 minute. Okay, so this is how we start. We assume let A be this thing, and I found I dot A, J dot A, K dot A. Okay, now let's start. So the left hand side, we have 3 different terms. Terms means separated by plus or minus. Term means, can you see the first term? Are you able to see the second term? Are you able to see the third term? The first term is a vector triple product. So I'm going to write the formula. Come on, tell me the formula. I, A minus I, A, I. Put dot, okay, plus the second term is another vector triple product. So I'm going to write the formula JJA minus JAJ. Put dot, plus KKA minus KAK. Okay, now you might understand why I made you do this. So by equation number 1, look, I'll be able to fill I dot A, J dot A, K dot A. So this becomes, tell me what is I dot I? It is 1 minus A1 into I plus, tell me what is J dot J? 1. What about J dot A? We already did it. We get the J component plus K dot K minus what is K dot A? The K component. So this becomes A plus A plus A is 3A minus A1I plus A2J plus A3 into K. That will be 3A minus. Do you remember how we started this question? Okay, we started like let A equal to, okay. So A1I plus A2J plus A3K is A. And that will give us 2 times A, which is the right hand side. So that's it. I'll be back with another very important video, that is reciprocal vectors. And they regularly ask one question based on what you call reciprocal vectors. So I'll be soon back with reciprocal vectors. So till then, my friends,